Every night, without thinking, we look up. A sky filled with stars stretches above us like a silent ocean. To our eyes, they are tiny points of light. Peaceful, beautiful, almost comforting. But that comfort is an illusion. Distance hides the truth. Some of those faint lights are so enormous that the human mind cannot truly comprehend them. Their size doesn't simply challenge our imagination, it destroys it. Tonight we're going to visit one of them. Not the hottest, but one of the largest stars humanity has ever discovered. A star so vast that if it replaced our sun, the solar system would no longer look like a solar system. It would look like food. Its name is Stephenson, 218, and somewhere, nearly 20,000 light-years from Earth, it is slowly approaching the end of its life. Before we can understand why that is terrifying, we have to begin with something much closer to home: the sun. For all of human history, the sun has been our definition of power. It dominates our sky. Its gravity commands every planet, every asteroid, every comet that calls this solar system home. Every second, deep inside its core, unimaginable pressure forces hydrogen atoms together, releasing enough energy to keep our world alive. Without it, Earth would become a frozen rock drifting endlessly through space. The sun feels enormous because, compared to us, it is. Its diameter stretches almost 1.4 million kilometers. More than 1 million Earths could fit inside it. Light, moving at the fastest speed the universe allows, still needs over 2 seconds just to travel from one side of the sun to the other. By every human standard, the sun is a giant. But the universe has never cared about human standards. Deep into the Scutum Centaurus arm of the Milky Way, this region is crowded with giant stars nearing the ends of their lives. Among them waits a red supergiant, unlike almost anything we've ever seen. Stephenson 218. Astronomers didn't discover it by simply pointing a telescope toward the sky. Its light had to fight through vast clouds of interstellar dust before reaching Earth. Only after careful observations did scientists begin realizing what they were looking at. The calculations seemed almost unbelievable. Could a star really become this large? Even today, measuring a star like Stephenson 218 is incredibly difficult. Its exact size is still debated, but if current estimates are close, it belongs among the largest stars ever discovered. Its radius is estimated to be more than 2,000 times larger than the Sun's. Numbers like that sound impressive. They also mean almost nothing. Because the human brain was never built to imagine thousands of suns. So let's bring the impossible closer. Erase our sun. Every planet instantly stops moving. The center of our solar system becomes empty. Now, replace it with Stephenson 218. You are looking at only a tiny fraction of its surface. That is the first thing Stephenson 218 steals from you: perspective. Standing near it feels impossible, because your brain searches for an edge that doesn't exist. Mountains have horizons, oceans have coastlines, even planets curve away beneath your feet. This star simply continues. Its atmosphere stretches across distances so vast they no longer feel real. And yet, despite its unimaginable size, Stephenson 218 is strangely cool. Its surface glows a deep crimson, only around 3200 degrees Kelvin, far cooler than the brilliant yellow surface of our own sun. That cooler temperature is exactly what allowed it to grow into a giant. As stars age, their outer layers expand farther and farther from the core. The energy spreads across an enormous surface, cooling the star even as its true power continues burning deep inside. Beneath that crimson glow lies a furnace beyond comprehension. Pressure, unlike anything on Earth, crushes atomic nuclei together, releasing enough energy to hold the entire star against its own crushing gravity. But Stephenson 218 is no longer living comfortably. It is surviving. Imagine stretching a balloon until the rubber becomes paper thin. Every additional breath brings it closer to bursting. That is the fate of every red supergiant. The larger it grows, the weaker gravity's grip becomes on its outer layers. The star begins losing pieces of itself. Powerful stellar winds race away from its surface, carrying billions of tons of gas into space every single day. Over thousands of years, those escaping layers create enormous clouds of glowing dust surrounding the star, a silent record of everything it has already lost. Stephenson 218 is slowly unraveling. Its surface is nothing like the smooth, glowing sphere we imagine when we hear the word star. It is alive. Immense columns of hot plasma rise from deep inside before cooling and sinking again in an endless cycle. These convection cells are almost impossible to picture. Some may span distances greater than the orbit of Jupiter. Imagine a single storm larger than the entire inner solar system. Not 100 storms, not 1,000, just one. The surface constantly shifts like a boiling ocean. Bright regions appear, dark regions fade. Massive plumes erupt into space before collapsing back into the star. Nothing about it is calm. Nothing about it is permanent. And every second, gravity grows stronger. Not because the star is becoming more powerful, because it is becoming weaker. For millions of years, nuclear fusion has fought a silent war against gravity. Fusion pushes outward. Gravity pulls inward. As long as those forces remain balanced, a star survives. But balance never lasts forever. Stars are born with a limited supply of fuel. The larger the star, the faster that fuel disappears. Ironically, the most massive stars live the shortest lives. While our sun will shine for roughly 10 billion years, hypergiants race through their lives in only a few million. Stephenson 218 has been spending its fuel at an astonishing rate. One day, perhaps hundreds of thousands of years from now, perhaps longer, the fuel supporting its core will finally begin to fail. Gravity has been waiting for that moment since the star was born. The instant fusion can no longer push outward with enough force, the balance breaks. The core collapses. In less than a second, layers weighing trillions upon trillions of tons crash inward. Temperatures soar. Matter is compressed beyond imagination. Then everything reverses. The collapsing material rebounds in one of the most violent events nature can produce. A titanic supernova, or perhaps something even more energetic, depending on the star's final state, erupts into the galaxy. For a brief time, the single dying star could shine brighter than billions of ordinary stars combined. Elements forged inside its core, oxygen, silicon, calcium, iron, are blasted into interstellar space. The atoms that one day become new planets, new oceans, perhaps even new life, are scattered across the galaxy by its death. Every atom of calcium inside your bones, every atom of iron flowing through your blood, was created inside ancient stars that lived and died long before the sun existed. The universe builds life from stellar graves. Stephenson 218 is preparing to become one of them. What remains afterward depends on how much of the star survives the explosion. The collapsed core could become an incredibly dense neutron star, or if enough mass remains, gravity may continue crushing everything inward until not even light can escape. A black hole, not a cosmic vacuum cleaner, not a portal, simply gravity pushed to its absolute limit. A place where space and time themselves become permanently distorted. Fortunately, none of this threatens us. Stephenson 218 is nearly 20,000 light-years away. By the time news of its death reaches Earth, humanity, if it still exists, will simply witness a brilliant new point of light appearing in the sky. Beautiful, silent, completely harmless from this distance. But knowing it exists changes something. It reminds us that the universe was never built to match human intuition. We spend our lives measuring mountains, cities, oceans, and planets. Then we discover something capable of swallowing worlds without noticing they were there. Stephenson 218 is not terrifying because it wants to destroy us. It is terrifying because it reminds us how small our definition of large has always been. Somewhere beyond the reach of our eyes, one of the greatest fires in the Milky Way continues burning. It has burned through the rise and fall of civilizations. It will likely continue burning long after everyone alive today is gone. And somewhere beyond even Stephenson 218, beyond the stars we've mapped, beyond the limits of our telescopes, the universe may already be hiding something even stranger, something larger, something waiting for us to discover that our biggest nightmare was only the beginning.